Hi guys, today we're going to do the 11.3 notes on hyperbolas. So I wrote out the definition for a hyperbola right here, the geometric definition. Basically a hyperbola is like two parabolas that kind of are opposite from each other. They're a reflection. It could be horizontal like this or vertical like this, and I'm going to show you both. It says a hyperbola is the set of all points in a plane, the difference of whose distances from two fixed points, f1 and f2, is a constant. So like any point on this hyperbola, I'll do P for point. If you take the distance from this focus to this focus and you subtract them, you'll get a distance. You take this point, focus to focus, and you subtract those lengths. That'll be the same difference as the other one. Put a point here, you go focus to focus, distance minus this distance, you'll get the same difference as the others. Here's a point, focus, focus. If I take this distance and subtract them, guess what? I'll get the same difference each time. So this set of points creates what we call a hyperbola. Okay, so a hyperbola, let's do a little chart here. A hyperbola can either be horizontal or it could be vertical. A horizontal hyperbola looks like this. A vertical hyperbola looks like this. Okay, so the equation kind of looks like the one for an ellipse, except there's a minus in the middle. And I don't know if you recall, in an ellipse, A is always the bigger number between A and B. But that's not the case in hyperbolas. There is no, A has to be bigger or B has to be bigger. There's no relationship between A and B. It's just that A and B have to both be positive because A and B are going to be lengths. They're going to be distances. So let me draw a hyperbola. Okay, here's the xy axis. I'm going to treat the center as the origin. All the hyperbolas we do in this section are going to have a center at the origin. So this would be the center. So if I have a hyperbola that opens horizontally like this, I'm going to label some parts. The distance from the center to, this is called a vertex. Okay, that's A. The distance from vertex to vertex is 2A, and that is called the transverse axis. So A will always be along the transverse axis. So basically, if you look at your equation, if it's x squared minus y squared, it's horizontal. If it's y squared minus x squared, it's vertical. So let me draw that here. Let's draw a vertical hyperbola. So like that. Okay, and so if this is the center, this is a vertex. This is another vertex, V for vertex. This here, that's A. This is A. So the length of the transverse axis, length of transverse axis is equal to 2A. 2, it's like A plus A. Okay, so where are the foci? Foci are inside of the little parabolas. So F1 and F2. And just like in an ellipse, the distance from center, the distance from center to focus is called C. So if focus is here and there's a focus here, the distance from the focus to the center is C. C will always be bigger than A. All right, C will always be bigger than A. C will always be bigger than A. Okay. B, this variable B, you can't really see in the picture, but I'm going to show you how to use it to graph. So in a hyperbola, there's going to be a set of asymptotes to help you guide how skinny or wide these parabolas are to make the hyperbola. So the asymptotes, they're linear. For a hyperbola that opens horizontally is going to be y equals plus or minus b over a x plus 0 because the y-intercept is 0. For this one, it's going to be y equals plus or minus a over bx. Okay? So I'm going to teach you how to use all this information. All right, let me do an example. Example 1, and I'm going to ask you to sketch the hyperbola. State the foci, vertices, asymptotes, and length of transverse axis. Let me just make sure you can still see. Yeah, okay. So what if I give you 9x squared minus 16y squared equals 144. So just like ellipses, you want this number to equal 1. So the first thing I would do is divide by 144 throughout, because the standard form of a hyperbola should equal 1. All right, so that produces 9 over 14 reduces down to 1 over 16. 16 over 144 reduces down to 1 over 9. And then 144 over 144 is 1. All right, since x squared is written first and then it's minus y squared, we know, if you look at our chart, that the hyperbola is horizontal, okay? The center will be at 0, 0. This will be a. All right, and it's always it's a squared as the first numerator, b squared as the second. A and b don't switch like they do in an ellipse. So if a squared is 16, that means a is 4, okay? And if b squared is 9, that means b is 3. Okay. We also want to find c. So I didn't say something really important in my chart. Let's go back. Oh my goodness. Let's triple star this. If you remember the relationship between a, b, and c in an ellipse, there was a formula. It was c squared equals a squared minus b squared. Well, in a hyperbola, it's just the Pythagorean theorem. This is super duper important, and I can't believe I forgot it. So we need to know that for hyperbolas. This is the relationship between a, b, and c. Okay, so in order to get c, I'm going to do c squared equals a squared plus b squared, which is 25. So c is going to be 5, because that's going to help us with our foci. So then I start graphing this. Okay, I set it up. I know the center is at the origin because we haven't moved our ellipse, hyperbola, or anything like that yet. We will in the next section. We'll have different centers, but for now it's at 0, 0. I know that since x is written first and then it's minus y squared, that the hyperbola is going to be horizontal. So what I do is I count a units, 4 units from the center. 1, 2, 3, 4. I put a dot, and that's going to be one of the vertices. I go 1, 2, 3, -4. That's going to be the other vertex. So I'm going to put V for vertex. And then I'm going to plot the foci, which will always be on the transverse axis. Foci are on the transverse axis, the same axis as the vertices. So if I go out one more unit, I have a focus. Focus 1, focus 2. And I already know that the picture is going to look like this. The issue is how wide or how skinny? Well, if you remember the thing about asymptotes, in a hyperbola where x squared is first, the asymptotes, if you look at your chart that we just wrote out, are y equals positive and negative b over a x. So that's plus or minus, b is 3, a is 4x. So here's what we're going to do. If I start at 0, 0, and I have a line that I have to, this is a slope. Slope is rise over run. I go up 3, 1, 2, 3, right? That's 3. Over 4. So if you kind of think of a rectangle, 1, 2, -3. This is called the box method, actually. Create a rectangle where you go out 4 and you go out 3 in each direction. you'll notice that this corner is up 3 over 4. Okay, same thing here. Up 3, left 4. You'll go through that dot. Basically, all I'm doing is y equals mx plus b, rise over 1, up 3 over 4. You don't need this rectangle, but it's kind of a nice way to do the asymptotes. If you just want to do rise over run, rise over run, rise over run, fine. So now you go to your vertex, one of them, and you sketch the hyperbola, and you use your asymptotes to kind of tell you how wide or how skinny you're drawing them. So the green is the actual hyperbola. Okay, let me move on and do another example. So example 2, make sure you can still see this. My paper keeps moving on my desk. Okay, let's see. Sketch and say all those things. Oh, you guys, I'm gonna go back. I forgot to say something. I forgot to answer all of the questions, my bad. So where are the vertices for this problem? Looks like positive and negative 4, 0. Where are the foci? It looks like they are at positive and negative 5, 0. The asymptotes I wrote out here, and then also I had a fourth thing. It was called the length of the transverse axis. And if you remember from the chart, the transverse axis is the x-axis for this problem since x squared was first, but it's from A to A. It's from vertex to vertex, from vertex to vertex. So the answer to this problem in this particular problem is 4 plus 4, so it is 8. Okay, sorry, now let me go on to problem 2. Same thing, and let's get all those pieces of information. So if I have x squared minus 9y squared plus 9 equals 0, first of all, I don't want the hyperbola in this form. I want it in the form that says equals 1. So I'll definitely move my 9 to the right as a negative 9. I want this to equal a 1, so I'll divide everything through by negative 9. And I'm going to get negative x squared over 9. This is going to be plus y squared over 1 equals 1. And then I'm going to write it how a hyperbola should be written in standard form, where the negative is in the middle. So y squared over 1 minus x squared over 9 equals 1. So you guys, we ended up with y squared minus x squared, which means our hyperbola is vertical. Okay, this is going to be the center, and it's going to open up and down, not left and right. Remember, this is going to be a squared. This is going to be b squared. So let's list some info. A will be 1 because a squared is 1. B squared is 9, which means b is 3. C squared equals a squared plus b squared, Pythagorean theorem. So c squared equals 1 plus 9, which is 10. So C is going to be rad 10. Now, in order to answer the question, I like to get a sketch started. So I know that the hyperbola, because y squared was first, is going to be vertical. So I'm going to move A units, 1 and negative 1, and label those as my vertices, V and V. And I know it's going to go like this and like this. Okay? Then I'm going to plot my foci, which deal with the letter C. And rad 10 is about like 3 point blah, blah, blah. I don't know. So I'm going to go 1, 2, 3-ish, put a dot, and I'm going to call that rad 10. Negative 1, negative 2, negative 3, negative rad 10, right? So F1 and F2, foci. So they're going to look, one little parabola is going to look like this, one of them is going to look like this, and then that 2 parabolas like that creates a hyperbola. Okay, now for the asymptotes. If you look at your chart, the asymptotes for a hyperbola that is vertical go a over bx. So it's positive and negative. What was a? It was 1, and then b was 3. So basically I go to the center, the origin, and I go, this is a slope. I go up 1 over 3. 1, 2, 3. So if this is the center right there, I go up 1, 1, 2, 3. And I connect and I make a line. And then I have to do the negative slope. So down 1 over 3. So that's a line with a 1/3 slope, and this one's a line with a negative 1/3 slope. And then I'm ready to graph. I'm ready to graph the hyperbola. I go to the vertex, and it looks like this is going to be a wider hyperbola. That's what the asymptotes are showing me. You use them to guide your picture. You don't ever touch the asymptotes, but you get closer and closer to them. So the vertices were, because they're going to ask you, what are the vertices? Looks like 0, comma, positive and negative 1. What are the foci? It looks like they are 0, comma, positive and negative, we're at 10. Asymptotes, I wrote out. And then they're going to ask you for the length of the transverse axis. And that, remember, it's vertex to vertex, V to V. So 1 plus 1, and that's going to be 2 in this problem. Okay. All right, I'm going to do one more example, and this time I'm not going to ask you to sketch, but I'm going to ask you to find the equation of the hyperbola. So, last problem here. Find the equation of the hyperbola with the given information. So it's got vertices at 0, comma, positive and negative 2. And then it's got two asymptotes, positive and negative 2x. Okay, so asymptotes. And that's all I'm going to tell you. Okay, so I have to sketch to see which equation I want. The vertical one or the horizontal one? Well, it's all about the vertices. So think about where 0, comma, positive 2, 0, comma, negative 2 is. 0, comma, 2 is here. 0, comma, negative 2 is here. Vertex 1 and vertex 2, which means the hyperbola opens like this. It's vertical, which means I want the one that starts with y squared minus x squared, not the x squared minus y squared, right? Also, for my picture, I know that the definition of A is the distance from center to the vertex. So it looks like A is 2. All right, I already have so much information. And if this is a squared, then it's going to be 2 squared minus x squared over b squared equals 1. So far I've got y squared over 4 minus x squared over b squared equals 1. The only thing I have to find is b, because all they want is an equation from me. They don't want c or anything like that. So I go back and I look at my chart, and it says that for hyperbolas that open vertically with y squared minus x squared, y squared first, the slope, this 2 over 1, is equal to, positive negative 2 over 1, is equal to, do you remember? A over B, right? It says positive and negative 2 over 1x is equal to positive and negative A over bx. This is what it says in the chart. Well, cross multiply, drop the x's, those aren't important. 2b equals 1a, which means b is what? A over 2. But we already know A. We already know A. A is 2, which means B is 1. So what I did is I set the slope of the asymptote equal to A over B, because if you look at our chart, that's what it says about asymptotes for vertical opening hyperbolas. So 2 over 1 equals A over B. I already knew A from this picture was 2, which, you do some math and you get B as 1. All right, I think we have our answer. Sorry, answer. Y squared over 4 minus x squared over b squared, but b is 1. So, 1 squared is 1 equals 1. Okay, so a few things to remember. The distance from center to vertex, let's write that down. Distance from center to vertex equals A. Distance from center to one of the foci, so focus, is C, right? And c squared equals a squared plus b squared. These are the 3 things you have to know to find a, b, and c. Okay, and that's the end of our hyperbola notes. If you have any questions, we shall get them answered, of course. Thank you.